Anyway, it's in the right spot, as long as it's on there. Okay, the question wasn't, though, break these down to components. Oh, does this make sense? These numbers are pretty close to each other. If a vector goes up at 45 degrees, should the two legs of the triangle be pretty close to each other?
Yeah.
If a vector went up at 45 degrees, they should be identical.
Because,
It'd be isosceles.
Because pi over 4 is the same thing. It's root 2 over 2.
Tangent pi over, excellent, because sine pi over 4 is equal to cosine pi over 4. That's a great way to remember it.
Yay.
Okay, so so if it's 50 degrees, it does make sense that these would be close to each other, but not exact. But the question wasn't just break those down into component form. The question was find the magnitude and direction of C. All right, so vector C, its magnitude is going to be the square root of... Oh, whoops, I haven't found C yet. I need to add the components together first, don't I? Yeah, so vector C is going to be...
Why is vector C A plus B?
It's going to, yeah, you're going to add the X components and add the Y components.
And how will that give you C?
That'll give us the components of C.
Oh, because it's in the middle.
Well, that's what you always do when you add two vectors.
What I did is
that's what we did yesterday.
plus B squared equals C squared.
Yeah, that's after I get the components. I was jumping ahead to that. But first I have to find that the 37.6 plus 48.2, from how we learned to add vectors yesterday, will get you 85.8. And then negative 13.7 plus 57.5 will get you 43.8. So Connor and Nick, you should have gotten this one correct and this one wrong.
Exactly.
Okay, yeah, because the cosine is the same as x, so the cosine of negative 20 is going to be the same as the cosine of positive 20. Okay? So those are my two. This is vector C in component form. Magnitude of vector C is a Pythagorean theorem situation. So it's 85.8 squared plus 43.8 squared. Put that in one string in my calculator and see what I get.
Wait, why is it square rooted?
I'm solving for C in one step. Otherwise it would be magnitude of C squared. But keep asking those questions. I don't want to rush through this too much, even though there's more I want to talk about today. And I'm getting 96.3.
Why do you need the square root sign if you have the stuff under it squared? It just cancels out, so it's just 85.
No! That's one of my pet peeves. No, Sasha. No, guys.
Classic.
Quick math lesson. No, oh my God. Ah! Hi. Nick and Sasha. Does A plus B squared equal A squared plus B squared?
Yes.
No, it's foiling. It equals A squared plus 2AB plus B squared. This is telling you to foil.
Yeah.
Okay?
So 2.
First, outer, inner, last, all that stuff. I don't have time to redo foiling.
No,
I'm sorry.
I understand foil. I don't
Okay.
see how that gets you that. Okay.
Are you serious? If you do A plus B times A plus B?
So I guess you do have time for
Oh, okay,
Yeah,
that's what it's telling you. Okay.
Yeah, squared means A
it
plus
just
B
means
times
write
A
it
plus B.
twice and okay, yeah,
Right.
I get it.
Now, so it doesn't mean distribute the exponent.
Yeah.
You never distribute an exponent
That's
across
what I'm thinking,
addition or subtraction. Because you never distribute an exponent across addition or subtraction, A squared plus B squared to the 1/2 does not equal A plus B. For this to be true, this would have to be true. And since this isn't true, this is not true. You can't distribute the fractional exponent, the square root, if there's addition or subtraction in the parentheses. You would have to FOIL it, and there's no foiling for square rooting. Okay, so we got to do this way. They can't cancel out.
So you're wrong.
That's okay. That's a common mistake. That's one of my pet peeves. I'm trying to deal with it. I'm talking to someone. No, that's fine.
Your management?
A little bit. So I'm glad you asked that, though. That clarifies things for more than one people. More than one people. I'm also taking grammar lessons, and they're going quite goodly. Okay, this is the magnitude of vector C. As I said yesterday in that chart, to find the angle of vector C, theta is the inverse tangent, or arctangent, of the y component over the x, 43.8 over 85.8 And that's going to be
Yeah, that's what I did.
excellent. Did you get the right? Well, how would you know? What did you get?
I think I get 9. Oh,
I'm getting 27.1 degrees.
9.
Your calculator might have been in radians.
Oh, I didn't even. No, never mind. Oh no, I just didn't even solve that. I just stopped.
Okay. Well, here is the magnitude and the angle. Now, quick check visually. Look at our drawing. Okay. Does it seem like if this is 75 and this is 40, it's reasonable to say that this is 96.3?
No.
Yeah.
Yeah, it looks bigger than the 75, but not like 10 times bigger. If this is 50 degrees, does it look reasonable that that might be somewhere around 27?
Yeah.
And it looks a little low to me, actually, but then again, my 50 degrees looks a little low. It should be a little more than half that angle, so that's not perfect. But these answers don't make me panic.
Nobody's perfect.
Nobody's perfect.
You live and you learn it.
That's right. If I'd gotten an answer of 10 million here, should I have worried that my math was off?
No.
No, not at all. If I'd gotten an answer of 217 degrees, should I have worried that my math was off? Maybe a little.
You didn't comment on my reference to the Miley Cyrus song.
I don't respond to Miley Cyrus. The longer I can pretend she doesn't exist, the better. All I can think of, and while I was in Barcelona this summer, I saw part of the video of her in the birdcage, and I feel feeling scarred for life. So, YouTube, Miley Cyrus, I'm not a little girl anymore, I just like dressing up like Giant Bird song. I don't know what else to say about it.
Music video to the...
Music video to what song?
Shit.
I'm kind of proud I don't know this.
I do know it.
Right.
Give me a minute.
No, I'm not going to hum it. All right, okay.
I said give me a
Hopefully
minute.
on
Right.
camera.
Yeah, all right, that's number 20, okay? May I erase number 20 now?
Yes.
Yeah.
Okay, now we're going to learn just a couple of new things that shouldn't be too crazy. And it's not really new things. What I'm going to do is talk about how vectors compare to what we've done before.
Scalars.
Yeah, well, actually, I'm comparing two-dimensional vectors compared to one-dimensional vectors, but you're close. Because we really have been doing one-dimensional vectors. Ever since I told you that direction matters
Can't be
with
tamed.
velocity. Can't be tamed, thank you. Glad we got that settled.
Yes.
That was vital. Our viewing audience was very concerned about that.
It was.
Okay, now,
All three of them.
all three of them, yes. My calculus lecture has like 90 views. What are you talking about? Most of them non-McLean
Why?
students.
Really?
It's because it's called Introduction to Calculus, and calculus is very hard. So that gets a lot of views from other people. I've got fans. I've got fans and...
Do you put other stuff on there besides math and
No, mostly.
physics?
Anyway, just people looking up for who would want help with math. Anyway, not talking about that right now. Talking about what we're doing now. Okay.
Notes or
Notes,
or
yes.
homework?
Notes. Okay. Ever since we talked about how velocity means direction, how there's a negative velocity and a positive velocity, even if you're just walking back and forth on a straight line, you guys have been doing vectors. You just kind of haven't known it yet. If I am...
Title the notes.
Okay, hang on a sec. Let's see. Title the notes.
Way more fun.
Way mo better fun. I'm sorry, I have no imagination today, so it's just going to be vectors. Displacement.
Maybe vectors, the cool things to do.
Yes, with displacement, velocity, and acceleration. Okay, so now I'm going to start with this. Okay, a displacement vector. When you're looking at a displacement vector, your book, well here, let's talk about this one real quick first. The tail of the displacement vector is going to be where you start. Now by you, I mean whatever particle or body we're talking about. We're talking about bodies soon, not just
You're not
particles.
super special.
That's right. Where